Welcome to this demonstration on how to submit a batch job to a cluster in EKM. I'm going to start by logging into EKM using a web browser. Once EKM is launched, I'll select Applications in the navigation pane. Here I can select the predefined Start Batch Job application or any custom job launch application that has been defined. I can also launch a job directly from a job template. I'm going to use a custom job template to submit a Fluent batch job to the queuing system of the attached HPC cluster. To start the batch job, I'm going to click on the job template. After accepting the default job name, which will be used for monitoring purposes, I am asked to upload input files to the working directory on the compute cluster. Input data can be selected from the local file system, the server-side file system, or EKM's data repository. I'm going to upload files from both my local machine and the repository to form a set of input data. For the first input file, I'm going to select the Local System tab. Conveniently, I can drag and drop a file from my desktop or a file explorer directly into the staging area of the Upload dialog box. Next, I'm going to upload an input file from EKM's repository, so I'll select the Repository tab. Here I'll click Add to have a look at the repository file system. I'll select an input file, then click OK. I'm satisfied with my input selections, so I'll click OK to proceed to the next step. With the input files now uploaded to the working directory on the compute cluster, I can specify my job submission settings. Because I launched the job from a job template, the fields in this dialog are already populated with the settings defined in the template, saving valuable time. Note that this template is just one example. You can easily create any number of custom job templates to suit your specific needs. Whether I use a template or not, I am free to specify or override any of the values shown. In this case, I can choose the queue, the number of cores, a journal file, the solver dimensions, and its precision. When I click OK, the job is added to the queuing system, and the job is displayed in My Jobs for monitoring purposes. Initially, the job has a queued status. When compute resources become available, the job will begin to execute, and the status will change to executing. Clicking Refresh lets me see the current status of the job. In the interest of time, I'm going to skip ahead to the point where the job has been executed. At any time during a run, I can select the Transcript tab to view detailed information about what has occurred. In this case, the transcript confirms that the job was executed successfully. Next, I'll select the Working Directory tab to access the results. The toolbar here enables me to interact directly with the working directory on the compute server. For example, I can transfer results files to my local file system or to the EKM repository. In this case, I'm going to select the case and data file and download them to the repository. As the files are being downloaded, EKM is automatically extracting metadata as well as a simulation details report from the files. An interactive 3D image may also be extracted if EKM is configured to do so. All of this information is displayed in a standardized format in the object view without any manual post-processing required. The simulation details report contains a static image of the simulation model, as well as information about model settings and boundary conditions. The navigation pane on the left provides an overview of the report contents, as well as quick access to each section in the report. Initially, the report is part of the simulation file, but I can copy the report to make it a separate object in the repository file system. I can also download the report to my local machine as an Excel, PDF, or XML file. This concludes the demonstration on submitting batch jobs in EKM.